Hi Math 2, this is Unit 7, Lesson 3, Practice Problems. So for number 1, you are supposed to state why angle BCA, which is an inscribed angle in my circle, is equal to the measure of ABD, which is this angle formed by my line tangent and my diameter. So these are actually two different reasons. So let's look at the two different reasons because they're important. So first of all, let's look at the angle, let's look at ABD. So the measure of angle ABD is equal to what? So let's take a look at this. AB is my diameter, and it meets my line tangent BD at B. So we've learned in this lesson that my line tangent is perpendicular to the radius, or in this case, the diameter at the point of tangent C. So I know that this is a 90-degree angle because in this case, B is the point of tangent C. Between my tangent line and my radius or diameter. So for a different reason, I also know that the measure of angle, and they call it BCA, I actually know that it's also 90 degrees, this angle right here. But this is an inscribed angle, and its arc is this arc that goes all the way from A to B. So if AB is a diameter, then I know that this arc is a semicircle. I know it's 180 degrees. And an inscribed angle is always equal to half of its arc. So since this angle has its endpoints on a diameter, I know that it's half of a 180 degree arc, or 90 degrees. So that's because it's an inscribed angle to 180 degree arc. So let's take a look at number 2. It says line AC is perpendicular to the circle at O. AC is perpendicular to the circle centered at O with a radius 1 unit. So it's perpendicular at its point of tangent C. And I know it has a radius of 1 unit. So from O to C is 1. Also from O to B is 1. It says the length of AC is 1.5. Find the length of AB. So that's that little length right there. Well, I can't directly find AB. I'm going to go about finding OA, this entire distance from O to A first, and then I'll use that information to help me find AB. So this is a right triangle problem. Specifically, this is a Pythagorean theorem problem. My hypotenuse is OA. It is my blue hypotenuse here is across from my right angle. So I know that 1 squared plus 1.5 squared equals my OA squared. So 1 squared is 1, and 1.5 squared is 2.25, and that's equal to OA squared. So 3.25 equals OA squared. Let's take the square root of both sides, and I believe you should get approximately 1.8 equals OA. So in order to find AB, I know that my entire OA is 1.8, and if I subtract OB, which is my radius, which is 1, my leftover part for AB is 0.8. So the measure of AB is equal to 0.8 units. So let's take a look at number 3. It says PD is tangent, so I know this is a right angle to the circle. I know my circle's radius is 1, so this OD is 1. I also know, like just up above, OC is also 1, because that's my radius. I know OA is also 1. So then it says the length of PD is 1.2. I can see that on my diagram. And AB, so that's only from A to B right here, is 1.7. And then it says which point is closest to P, A, B, C, or D. So really, my real choice as far as what's closest to P is going to be between B and C, just looking at my diagram. So it would be helpful for me to know this distance, BP, and also the distance from P to C. If I knew those two distances, it would give me something to make a decision. You might say, oh, well, C looks closer, I'm going to pick it. Mathematically, we need to be able to show that's true. So I'm going to use two different right triangles, and I'm going to use the Pythagorean theorem twice. So the first triangle I'm going to use is this triangle right here, just like I did in the problem above. I'm going to use this triangle right here to find the difference from P to C. I kind of colored on top of my C right there. So let's find my distance from P to C. So we're going to do the PC one first. So I have my hypotenuse is from O to P. That's my longest side. So I know my 1.2 from P to D squared plus my 1 squared, which is from O to D, equals my hypotenuse O to P squared. So 1.2 squared plus 1 squared, I believe gives me approximately 2.44 equals my OP squared. Let's take the square root of both sides. And I'm going to get approximately 1.56 or 1.6 is equal to OP. So I don't need to know the distance from O to P. I need to know the distance from P to C or C to P. So I'm going to subtract out the 1. So 1.56 minus the radius of 1 gives me 0.56. So from C to P is equal to 0.56 units, okay? So now let's find out how far B is to P. Okay, so this is a different problem. This is from B to P. So I'm going to use a different triangle. I'm going to use this red right triangle right here to calculate that distance. So I know from PD is 1.2 squared plus, and in this case, my hypotenuse is going to be from A to P. So this entire AD is my other side. So it's going to be 2 squared. A radius of 1 plus a radius of 1 is 2. Equals then my hypotenuse, AP squared. So 1.2 squared plus 2 squared is going to give me 5.44. That's equal to AP squared. I'm going to take the square root of both sides. And I believe you're going to get around 2.3 or 2.33 is equal to AP. Now, AP is not the distance I wanted. I really wanted BP. So I'm going to take that entire distance minus this 1.7 from A to B. So I'm going to take my 2.3 minus my 1.7, and I'm going to get approximately 0.63 for my distance from B to P. So B to P is 0.63. So now I can really evaluate this. It says which point is closest to P. So point A is not, because point A is 2.3 units away. B is 0.6 units away. C over here is 0.56 units away, and D is 1.2 units away. So it looks like C, and you might have said, well, it looked like C the whole time. I agree, but I've just proven with the math that definitely C is closer. Let's take a look at the page, shall we? So this is getting back to some problems from previous lessons with inscribed angles and central angles. So it's telling me that the arc not passing through C, so the smaller arc from A to B is 50. So I know a lot of things from that. I know that angle O is 50 because a central angle is equal to its arc. I also know that angle C is 25 because an inscribed angle is equal to half of its arc. So that will help me answer the questions here, and you can find those answers in the locker. So then in number 5, it says chords A, B, and DB intersect at point E. List the pairs of angles that must be congruent. So this is going back to an activity we did in the previous lesson where we proved the two triangles similar. So in this problem, I'd like to point out that I have this arc DC. And in this diagram, arc DC has two inscribed angles, A and B. Both of those angles, sides, meet at DC. They both share that arc, so they would share the same measure. So I know that Angle A is congruent to angle B because they are both inscribed angles. Inscribed. I think I forgot a C somewhere. Sorry about that. If I can fit it in without being too messy. Inscribed angles to arc DC or CD. I also know, let me get a different color here. I also have this arc AB. And in my picture, I've got two inscribed angles whose vertices meet at AB, and that's both D and C. So D and C would also be congruent. So angle D would be congruent to angle C because both are inscribed, I did it again, sorry about that, angles to, in this case, arc BC, or arc AB. Sorry about that. And then lastly, on this diagram, I've got two vertical angles. They're on either side of E. And I know my vertical angles are congruent. So angle BEC, or you could write CEB, is congruent to angle, in this case, AED or DEA, because vertical angles are congruent. And then let's see what we found on page 3, shall we? So on page 3, it says this image shows a circle with these two diameters. Prove that the chords BC and AD are congruent. In this picture, you're going to use congruent triangles. So you're going to use some things that you know to show two triangles are congruent. And then my green lines, my green chords AD and BC will be congruent by CP, CTC. So you can take a look at that in the locker. And then on number 7, this is my point slope form. It gives me a point and the slope of a line. And then it says that I do this transformation on it. So if you want to think about what that transformation was, it's taking some xy point to negative x, negative y. And so it's asking me to write what's the slope of the image. So you need to think about that line when you rotate it in such a way to do this transformation, what would occur with the slope. So we've seen this similar type of problem before. And again, the answers are in the locker. If you have questions on this or any of the other problems, make sure you bring them to our Zoom. Thank you.